All right, let's take a look at our lesson on solving linear systems. This also should be a review. So we're just going to do one of each of the three different types of solving. We'll start with graphing. So it's easier to graph a line if you have it into slope-intercept form, y equals mx plus b. So let's do that for the first line. So this line we're going to do y equals negative 2x minus 5. Alright, so let's see, our y-intercept is negative 5. 1, 2, 3, 4, 5. Our slope is a negative 2, so rise 2 and run 1. Okay, so let's see if we can draw our line. Now, using graphing is not the most accurate way to find the intersection of the lines. So remember, solving means finding the point where the lines cross, if they ever do cross. And so we would need to have an integer solution to be able to successfully do solve by graphing. Just kind of a little shout out there. And of course, unless you're using a calculator. All right, for the next one, let's work on it. So I'm going to move the 2y over. So 2y is x. So y equals 1/2 x. Okay, so that one, let's see, the y-intercept is 0. My slope is rise 1, run 2. So let's get that one drawn. I love this ruler thing. Okay. Now you can see from my drawing that I'm a little off, but if I were to do my slope of, you're going to go run 2 and down, so it really, the green one does go through that point. So the solution to this particular system is our y, let's see, x would be negative 2 and y would be negative 1. That would be our solution. All right, so now let's take a look at our second type, which is solved by substitution. And it really doesn't matter which equation you use and which variable you solve for. I'm just going to remind you, so what do? We take one equation and then we solve for one variable, and then we plug or substitute into the other equation. I like to write it in words just so we can kind of get the idea in our mind. So this is a technique for substitution. So let's do that. And what I would do, I would rather, if I find just a variable with a coefficient of 1, that's what I'm going to solve for. That seems the easiest thing to do. Do I have to? No. I could pick that one if I wanted to and solve for this one, but that would mean I would need to divide by 2 and create some fractions. It just gets a little messy. So I'm going to solve this one for b. So b would be 7, then I'm going to move the 3a over. So we successfully did that. Now what we're going to do is we're going to take this, what b equals, and we're going to go up here and we're going to replace this b. We're going to substitute this information into that b. Just kind of a reminder on how this technique works. So I'll have 6a minus 2 times, here's where we replace b with this information, 7 plus 3a equals 5. Now we have one variable and we can just use our normal algebra techniques to solve this. So let's distribute the negative 2, which would give us what? Negative 14 minus 6a. Then we combine like terms. Oh, this one's a little crazy. Look, the 6a and the negative, those go away. So I'm left with negative 14 equals 5. Now let's kind of pull back into our memories. Do you remember what does that mean when you're left with an untrue statement? Is it true that negative 14 is the same as 5? Well, no. So that is not true. And what that means is that this particular system has no solution. Now let's look at another option. What if, so just an example, this isn't this problem, just an example. What if you were left with a true statement? So left with a true statement like 2 equals 2. What about that? If you remember, if you're left with a true statement, then that means that there are infinitely many solutions. I hope I spelled that right. Infinite, probably not. Infinitely. Infinitely. Bear with me. I probably don't have it spelled right. I apologize. I'm sure many of you are way better at spelling than I am. Infinitely many solutions. That would be the other type. Okay, so there's solving by substitution. Let's go to our third and final technique that we're going to be working on today, solving by elimination. So if you recall, elimination is where we're going to decide which variable to get rid of first. So this technique, what we want to do is we want to get rid of or eliminate one variable. Again, it doesn't really matter which one you choose. I can get rid of the p's or the q's. I'm going to choose the q's because they're already opposite signs, and I like adding. I don't know about you, subtracting is dangerous. So instead of subtracting, I would much prefer to add. So I'm going to work on getting rid of the q's, which means that I would need to multiply this top equation by 2, and I would need to multiply this bottom equation by 5 in order to accomplish that, so that those would net out to nothing. All right, so let's do that. So let's distribute the 2 to the top equation. That gives us 8p plus 10q equals 14. Then do the same to the bottom equation. That gets, so 5, what is that, 15p minus 10q equals, and 5 times 34 happens to be 170. So here we're able to now add them together, and you can see those go away. 15 and 8 is 23, and 170 and 14 is 184. And crazily enough, 23 does go into 184 evenly, so p is going to be 8. Now once we find out what one of the variables is, if you recall, we do, I guess you could call it back substitute. We're going to take that p equals 8 and we're going to plug it into one of those equations at the top. Doesn't really matter which one, whichever one you want. I'm just going to use the second one, I guess. No real reason why. Either one of them is fine, but I'm going to use the second one. So 3 times, and we know p is 8, minus 2q equals 34. So let's see, what does that give us? That gives us 24 minus 2q is 34. So we've got, let's see, 34 minus 24 is 10. So q is negative 5. All right, so we really need to put these two together, and since we don't have x's and y's, we could actually leave, p equals 8, q equals negative 5 if we wanted to, or a common practice would be able to write the point in, like alphabetical form, p and then q. whichever one you prefer. If you would rather just leave it p equals 8 and q equals -5, that is perfectly fine. Okay, or you can write it in alpha order, so that would be 8, -5. All right, this takes us up to our very last problem. You know, we're going to have a lot of fun with word problems. I know you guys probably love them. All right, so on a college entrance exam, you answered 80 of the 85 questions. Okay, so let's keep that in mind. That means that, you know, we didn't answer 5 of them. Okay. Each correct answer adds a point to the raw score. Each unanswered question, each unanswered question adds nothing, and each incorrect answer subtracts 1/4 of a point. So let's think about that for a second. If the unanswered questions that we have do nothing, then really this information right here, the 85, we really don't need that at all. Doesn't really matter in our score. So let's just kind of ignore 85. We really want to be working with 80 because it's 80 questions that we answered. All right, so the raw score was 70. How many questions did we answer correctly? So how many questions did we answer correctly? That needs to be a variable, right? I mean, we want to assign variables. How do we know what to assign them to? Well, it'd be a pretty good clue, seeing if they're asking us how many questions we answered correctly, we probably need to put that as a variable. So that means the other variable would be incorrect. So again, it doesn't matter which one you make what. I decided to make x equal the number of incorrect answers and y is going to equal the number of correct answers. Okay, so we have defined our variables. Great. Let's see. So we know that we answered 80 questions. We know that the number we got incorrect plus the number we got correct, I mean, that would have to equal 80, right? Because those are the only options for the questions that we answered, either they're right or they're wrong. Great, we have one equation. Let's see what our other equation needs to be. Looks like we're putting values with variables. See, we have 1 point. Each correct answer adds 1 point to the raw score, and incorrect subtracts 1/4 of a point. Let's see. So our correct answers are represented by y. So that would be 1 point for y's, and then we're supposed, so that's how many points we would get, right? 1 point for each y, and then we want to subtract 1/4 of a point from all the ones that we get wrong, and the value, our end value is 70. Okay, great. Let's see. We could do elimination or substitution. It doesn't really matter. I decided to do substitution. Why? I mean, who knows? But what I did is I went ahead and I took this equation and I solved it for y. So I moved the 1/4 x over. And then I'm just going to take this information and I'm going to substitute it right there. All right, so we have x plus, and then we're going to take out the y and put that in its place. 1/4 x plus 70 equals 80. Okay, let's see. And of course, 1 we could write as 4/4. So 4/4x plus 1/4x is 5/4x. We move the 70 over, and we get 80 minus 70 is 10. Now, if you recall how to solve for x when you have a fractional coefficient, one way, I think the fastest way, but one way would be to simply multiply both sides by the reciprocal. So we know 4/5 times 5/4 is just 20/20, which is 1. Let's see, 5 goes into 10 twice. 2 times 4 is 8. So we know that we got 8 problems incorrect. All right, so let's translate our information into numbers. So 8 were incorrect, and we answered a total of 70. So let me do a little scratch work over here. So if I take away the ones that I got wrong, then what do we have? Oops, no, we answered 80 questions. 70 was the raw score. 80 was the total questions we answered. So 80 minus 8, that gives us 72. So we got 8 incorrect and 72 correct. Okay, there we go. And that concludes our review lesson on solving systems.